Welcome back, and today we will be looking into some recurrence relations and how to solve them to get the time complexity out of them. So we will be using the substitution method, and let us look into the very first question. This is one of the simplest recurrence relations to solve to clear your concepts before moving into the complex ones. So let us solve this. Let us first look into what the question means. So over here we need to find the time complexity of this particular equation. Means this equation is derived from a particular algorithm, so which you have seen in the previous videos. So is a ready-made equation given to us, and this is the base case. So this is the base case, which is this will be used at the end. So let us start. So we need to take out the general equation out of this. So T of n equals to T of n minus 1 plus C. How do we proceed? As the method name is substitution, we have to repeatedly substitute and unroll the carpet. Now we need to substitute T of n minus 1. So if T of n equals to T of n minus 1 plus C, T of n minus 1 will be what? We will just replace n with n minus 1. So T of n minus 1 for the n minus 1 plus C as it is. So T of n minus 2 plus C. We will substitute that over here. So T of n minus 2 plus C. And this C goes here as it is. Now the same thing we need to do with T of n minus 2. So T of n minus 2 equals to T of n minus 2 minus 1 plus C, which is T of n minus 3 plus C. So we will first simplify this and write T of n minus 1 plus 2C. So T of n minus 3 plus C plus 2C. Simplifying this, we get 3C. Now the same thing goes with this. So T of, if we follow the pattern, we get T of n minus 4 plus C plus 3C. Okay, so what we got was T of n minus 4 plus 4C. Now if we continue the process, we will get T of n, we will get a general equation. Let us substitute the constants with something called K. So same thing goes here. Okay, because if we see over here, when it was n minus 1, C into, we can write C multiplied by 1. When it was n minus 2, we had 2C. When it was n minus 3, we had 3C. And for 4 also it goes, when we had n minus 4, we had 4C. So if we have n minus k, we will have kc. Now remember what our base case was. It was T of n, just a minute. Yes. So T of 1 was 1. This was our base case. So we need to replace n minus k with 1. So what do we get? N equals to k. We will need this. Okay, so we are substituting. So 1 plus, now what is the value of k? It's n. So let us write n into c. So what is t of 1? It is 1 plus n into c. Now 1 is a constant term that doesn't affect the growth pattern. The growth is affected by n because it dominates the whole equation. So what we can write is the time complexity is t of n is big O of n. This grows linearly. The algorithm has a linear growth, so it is a linear, you can say this is the time complexity out of the recurrence relation. Now, so yeah, let's have a quick recap of what we did. We just found the base case from the question, then we found the general equation of the recurrence relation, we applied the base case over here, and we got the time complexity. So now what your homework is, you need to find which algorithms have this time complexity, and don't forget to comment it. And for more such videos, do follow, subscribe our channel, and like and share it with your friends. Thank you.